Exercise 3 said 2 ladders are pitched together as shown here. One ladder is 11 metres and the other is 13.5 metres. They make an angle of 95 degrees. Determine the height to point A and the distance to point B. That's what they're trying to work out now. We're trying to work out the height to point A and the distance to point B. In this case, we need to try and go through the 5-step route first. The 5-step route. Don't forget what it is. Canadian swans prefer smaller insects. Firstly, convert to right-angled triangles. So what you do is you make that a right-angled triangle by drawing a straight line down the middle. That makes a right-angled triangle. Secondly, the second one is S, sum of all angles. We know the sum of any triangle is 180 degrees. Now we know 2 angles are 95 degrees and 60, so we know 2 of them. Therefore the final angle there is 25 degrees. That's there. We can put that straight in, 25 degrees. The third step is Pythagoras' theory. The sum of the hypotenuse is equal to the sum of the other 2 squares on the other sides. Now to use this rule you need to know the length of at least 2 sides. In this case we don't, we only know one length. So we can't use Pythagoras' theory at this point. We can't, because you need to know at least 2 of the lengths to use Pythagoras'. So let's go on to step 4. Step 4 is SOHCAHTOA. Do we know an angle and do we know a length? Yes we do. Now, as you can see, we know the hypotenuse. We're trying to determine the length opposite. So, what function has got the function for opposite and hypotenuse? Well, it's a sine function, SOHCAHTOA. So the sine of the angle equals the opposite divided by the hypotenuse. Therefore, the sine of 60 degrees equals the opposite divided by 11. So the sine of 60 degrees is 0.866 equals opposite over 11. Multiply it out, you get 0.866 times 11 is the opposite. That length there is 9.526 metres. So we have worked out the height from A to the ground floor. Let's determine now the distance to point B. Now, because we know the angle ACB and we've got the lengths of 2 sides, we could determine this in 2 different ways. We could use Pythagoras' theory, which is A squared plus B squared equals C squared, or we could use SOHCAHTOA. Do you understand? We can use both methods to solve this. Let's use the SOHCAHTOA principle for this one. We know the angle's 25 degrees and we know the hypotenuse is 13.5. We want to identify the adjacent. So which function do we use? Which function do we use when we know we've got the adjacent hypotenuse? Well, because we've got those, we use the cosine. Therefore, the cosine of 25 degrees equals the opposite divided by 13.5 metres. Therefore, you bring it out, it's 0.906 equals the opposite divided by 13.5 metres. Transposing this would have given you 0.906 times 13.5 equals the opposite. Therefore, the opposite equals 12.23 metres. That's the answer. 12.23. That has solved that exercise. Now, as you can see, knowing these rules, you can virtually answer all questions using arbitrary triangles by using these laws. The laws of sines, cosines and tangents using Pythagoras'. But my rule is good. Canadian swans prefer smaller insects. Go through that step and you can virtually solve any problem involving trigonometry and angles, because you can convert them all into triangles and you can use those functions. These laws can be used to compute the remaining angles and sides of any triangle, as long as you know either 2 sides or 1 side and an angle. Now, these laws are useful in all branches of geometry, since every polygon may be described as a finite combination of triangles. In other words, any polygon you can create loads of triangles and use these problems.